Okay, so we will now start talking about electron configuration. So the reason with electron configuration, it kind of gets to what the electrons look like surrounding an individual atom. So, for example, if we take, say, carbon, we'll take a look at that. So carbon So if we take a look at our periodic table, you see that carbon has an atomic number of 6, which tells us that the number of protons is equal to 6. So for a neutral carbon atom, one that doesn't have a charge, then the number of electrons is equal to 6. So what does that look like? So if we think of the nucleus here with, say, 6 protons, let's say 1, 2, 3, 4, 5, 6. And then we also do have 6 neutrons in there. 1, 2, 3, 4, 5, 6. So what do the electrons look like? We've got 6. Does that just mean we've got 6 all around it? 3, 4, 5, 6. So it turns out those 6 electrons aren't evenly spaced around it, so that is wrong. One of the things about electrons is that they surround an atom in shells or orbitals. And these are, a way to think of these, they're like layers of an onion. And each orbital can hold a certain number of electrons. So it happens that the first orbital which is the innermost shell closest to the nucleus, can hold 2 electrons. And interestingly, if we look at the periodic table, period 1, we've only got 2 atoms, hydrogen and then helium. 1 electron, helium has 2 electrons because it has 2 protons. So, first shell, 2 electrons. Second can hold 8 electrons. So if we know that the second can hold 8, what do you think we'll see if we look at the second period, the second row on the periodic table? 1, 2, 3, 4, 5, 6, 7, 8. So you see, that seems to line up. So if we take one more look at the periodic table, going down one more row, one more period, we look here at the third period, 1, 2, 3, 4, 5, 6, 7, 8. So based on that, what would you say is a good guess for the number of electrons that can be held in the third shell? Well, same as what we'd seen there, 8 electrons. So The way that we can conceptually think of this is that if this is our nucleus here, so I'm going to make it a little bit smaller, but that's our nucleus. In this first shell, we've got the space here for 1, these are not to scale, and a space here for 2. In the second orbital, the second layer, the second shell, we've got 1, 2, 3, 4, 5, 6, 7, 8. And then if we look at this third layer going further out, we've got another 8. 1, 2, 3, 4, 5, 6, 7, 8. So that's kind of the first way when we look at electron configuration, is that we start looking at this layer system. And that 2 in the innermost layer, 8 on the layer outside of that, and 8 can fit on the layer outside of that. So that gives us 2 plus 8 is 10 is 18, which, looking at our periodic table, we've got 2 plus 8 plus 8, argon, atomic number of 18. So that gets us up there.